Alright, here's a ZVS circuit that I put together using some IGBTs I pulled from a TV board. They worked out much better than a couple I had wound myself on these toroids, and I had two of these I wound to bring them to 90 microhenry, and these were just getting way too hot. It wasn't the wire, because the wire itself would be relatively cool, but the core itself was pretty sure it was just oversaturating. Right now 26 volts or so on the power supply, and when I switch it on, see, we're pulling about an amp and a half, and when I pull arcs from it, it doesn't even quite max out the supply. It goes up to about 4.5 amps. Yeah, this little garbage tie wire. Whoa, sparklers. Garbage tie wire doesn't last long. It does make a pretty good sparkler though. Hey. He almost wanted to break off, but he refused himself. Nice. Yeah, not bad. I mean, nothing major, no huge arcs or anything, but these are nice little, mini fun arcs just to sit and play with. That I can get away with from this, 5 amp bench supply. I just have to crank it up to about 26 volts. But already just playing with this, pulling the arcs that I have been pulling. While the only thing on this circuit that actually gets hot is the capacitor at this point. Inductors are great. They're doing the job. The flyback is actually starting to get pretty damn warm. So I'm not really sure how long that would last. There's so much juice swinging out of these transistors that this whatever capacitor is here is getting worked overtime. So if I was to place, basically what I noticed was I threw a clip lead on one leg to test out different caps, and that wire was getting extremely hot. And if I was to throw this 0.1 ohm resistor in series with this cap, this thing is going to get so hot so quickly, I could probably fry some bacon on it. This is a little guinea pig rig I set up for the ZVS. This one's got the center tap set up using the single choke. With this setup, this cap right here does not get hot at all. It does not get warm, and I've got relatively puny leads on there, which don't seem to have any effect on the circuit. The cap doesn't get warm even when I'm pushing about 100 watts. And I've got my center tap outputs here on this flyback core, and so I've got my 5 or 6 turns secondary right here, and then I've also got this fat gauge wire of about 3 turns or 2 turns. I guess you can count that as 3 actually. So that'll end up being about 3 turns. Whoops. You see already that if I was to simply short this little fat turn 3-turn secondary out, I get a lot of current, but the current that I'm getting is dependent upon the resistance. There has to be some level of resistance formed, which actually occurs the moment I make contact and the wire heats up, further driving the circuit to push some amps. But you can see it's maxing out at about an amp. It's not going to pull more than an amp or so, even though I can already tell this fat silicone wire is getting too hot to touch. There's a lot of amps going there. But as you saw, if I use a much thinner wire, let's try this wire right here. It's not quite as thick. When I do that, I'm driving it closer to a couple amps. So I'm getting even more current through there. And as I showed earlier, if I put a 0.1 ohm resistor on there, that thing's going to push 5 amps or more, and it's going to burn that little sucker out, no problem. So I've got a little, what you could consider a high frequency 1-to-1 transformer here. But if you'll notice, I've got this coil hooked up to this coil, and I'm not pulling any extra power. So even if I unplug it, I'm still pulling the same juice, and then I'll plug it back in. Does not change the operation of the circuit at all. That does nearly absolutely nothing. Doesn't hurt the circuit at all. But as you saw before, directly shorting out the wire is going to pull a load on it. Adding more resistance is going to put even more of a load on it. It's got about 25 AC volts on it, and this has about 3 volts. So with the 25 volts, back down to half an amp, which it won't do if you provided way less resistance with this one fat wire, silicone wire, which can handle the juice. I'll short that out. I'm only drawing about an amp across there, whereas that's pulling about 5 amps. Whew. If I use this extremely thin wire from this clip lead, which has the same number of turns as this fat gauge, then what'll happen is it'll draw a little more current, but all that current is going straight into the wire, and it's heating up that wire, and that's going to burn out. If I use this pair right here of higher turn, the gauge is also not quite as thick. It doesn't really do anything, so even as before, like I showed, just shorting that out like I'm doing right now, it actually dropped. Well, it doesn't really change. I'm shorting it, unshorting it, doesn't make much of a difference, especially with this hooked up. So a lot of ZVS setups, will be able to do this from only about 12 volts input or so, I'd say. Here I've been pulling like 30 watts. That's not bad. I'd say those setups are pulling about the same amount of power to do the same thing here. Even though I've got another middleman going on, they just are pushing more amps at that lower voltage, and so clearly this sucker is hot. Man, that sucker was hot. Jesus. This wire right here is still doing alright. I'm curious to know how it would work out with much thicker gauge wire on both of these coils, messing with the turn ratio there, because that's satisfying to me if I could get something like this to go with just a bench supply and actually be able to heat up some things significantly. And you know, if I put something about this size in there, that's going to heat up tremendously quick. And it's pulling a couple amps, and already that got so hot almost that I can't touch it. Take a little ferrite tuning rod, which was probably from a radio, and we're at 600 milliamps. You put that in there, it actually drops the current draw down to under 500 milliamps. This core material will never heat up. Decided to crank it up some, so now I'm 26.5 volts, and I've had this actually on here for a while. It's really hot. Been about 5 minutes, but I didn't have any thicker gauge wire than this, than number 12 solid, so I just paired two of them up and wound this real crappy looking pancake. These little guys right here work, but I just wanted to see what thicker wire would do. I'm pulling roughly the same amount of power as I was before, with everything running, and not until I put that on does it pull up to about 1.8. So basically increasing the circuit voltage, all that did was just increase the amount of power I can put into my whatever I'm trying to heat, and overall stays the same. And if I raise the voltage up enough by getting a little coil with enough turns on it, because something like that does not produce enough voltage to even light an LED, but something like this coil, you can see, let's get my little power in there. It's not too great, but I say you can wind a much better coil. Just an interesting circuit, so fun to play with. But notice now, using the sticker gauge, winding the coil doesn't seem to perform so much better than this one. It's just the difference is it doesn't get quite as hot. It'll sit at about 12-13 watts. If I take, like, see, I've already been melting this guy a little bit, but if I put this little guy in there, I'm just going to let him chill in there for a little bit, and he doesn't pull a whole lot. It's bringing it up pretty much doubled the current draw. So this is let's say 30 watts or so power that it's pulling. I've got a little baby fan right there that I'm just blowing on that capacitor, because that's the only one I've got that'll work, and I'm not trying to pop it, but just kind of get an idea of, at this wattage, how long it'll take to heat something up to super hot. I've heated some other larger things, but those are the type of things that are not going to get flaming red hot. This little guy right here actually will, but I just think it's interesting that something so small you put in there, give it enough time, still get crazy hot. So most setups, you got to push about 150 watts or more to really make this practical, but this is sort of just the low power demonstration. It's just cool to me. But yeah, there definitely are better ways to do it, but I just find the way these different coils interact with each other, how that works, is just pretty interesting. But so this, I don't know if you can see, but it is getting red hot in there now. So it's been maybe a couple minutes or so now, but that sucker is getting hot. Just gonna leave it in there for a little while longer. Yeah, eventually I'll probably try to get another choke that'll work out as good, and wire this with the just a 2-wire output, no center tap. See if I can get a little actual better efficiency. But I think this isn't bad. Ooh. And he's falling out. Whoops. He's falling out the plastic there. Let me see if I can get him right. Yeah, that's hot enough to probably start a fire there. Also with this circuit, if I add these capacitors in there at 2.2 microfarad each, put them in parallel, put them in series, drop it down to closer to about 1.1. Not a bad little arc. I want to say this arc almost gets hotter than the other one because this little screwdriver tip gets stupid hot pretty quickly. Alright, so I ditched the core there, and I'm going straight to this flyback now. Same circuit. I noticed with the other setup, the primaries on the other flybacks were getting really hot. The flybacks themselves were getting really hot. And this circuit actually ran pretty good from 12 volts, so I wanted to see what it would do from about 16 or so volts, which is what the batteries are at. And this would be the current draw, so when I cut it on, it's no arc, about 1.3 amps, and then I can pull. I can pull about close to about 9 amps from it tops, from a peak arc, and you can tell that's kind of it seems to be that's what the batteries will take. I don't think they can really push out more than that. That's pretty impressive. So they're sagging at about 15 volts or so, so I'll be real curious to see what these will do at much higher voltage. I'm thinking those fets can take it. I really don't have any data on them. They just look fat and beefy, and their own heat sinks that'll knock out your grandma. But yeah, already the cells are drugged down pretty good, so I'm gonna see what another drill battery does. Alright, now I got this sucker on here. It's drill battery. It should hold up for a little bit, and hopefully so will the fets. That sucker started to screech. Yeah, so we getting real good arcs off that. Woo. Yeah, it's real late, so I don't want to screech it too much.